This tutorial is going to show you what to do when we divide radicals, which can be a little bit lengthy, so we're going to start off slow. This particular problem in number 1 says the square root of 20 plus the square root of 5 over 2. And I just want to make this as simplified as I possibly can. So the first thing that you want to do is try to find any radicals that are not simplified on their own. And I'm looking at the square root of 20 and I'm thinking that's not simplified because it's not prime and it's not a perfect square. Now, in the previous examples, we have seen that the square root of 20 is the same thing as the square root of 4 times the square root of 5. And I'm just rewriting everything else right now. And the square root of 4 is the same thing as 2, so this is 2 square roots of 5 plus the square root of 5 all over 2. And so I have like radicals in the numerator, so I'm going to combine them. So 2 square roots of 5 plus 1 square root of 5 is 3 square roots of 5 all over 2. And if I can, I could reduce these two numbers here, the coefficient of the radical and the denominator. However, there is no simplified version of either one of those, so this is my final answer. There's nothing else I can do to that, so I am done. Let's take a look at another example. Okay, so what if I've got something like this? So I check my radicals, and I notice that they are prime, so there's no need to simplify them anymore, so I can go right ahead into my simplification. So 3 square roots of 5 plus 1 square root of 5 is 4 square roots of 5, and this is over 2. And just as I mentioned before, if these numbers here can be reduced, we are going to do that. So 2 goes into both 4 and 2, so this becomes 2 square roots of 5 over 1, but of course we never write the over 1 part. So I'm going to take those away, and that's my final answer. All right, let's take a look at one more. All right, let's take a look at this problem. It says, I'm going to make my partition there, 2 square roots of 2 plus 3 square roots of 6 minus the square root of 6, all divided by 2 square roots of 6. Now, first of all, I'm going to take a look and see if my radicals are all simplified. The 2 is prime, so there's nothing else to do about that. 6 is composite. However, when I think about the factors of 6, 2 and 3, both of those numbers are prime as well, so that is not a perfect square. So that means I can go right ahead into this and start simplifying. So 2 square roots of 2 is not going to be able to combine with anything, so I'm just going to keep him here. Now I have 3 square roots of 6 minus 1 square root of 6, which gives me 2 square roots of 6. And this is all over 2 square roots of 6. Now, just like what I've been telling you recently when we've been doing our trig proofs, if there is something in common between all three terms or all of your single terms, then you can take them out. You can cancel them. So here I see a 2 in this term, and I see a 2 here and here. So that means I can cancel all three of those. So this is the square root of 2 plus the square root of 6 all over the square root of 6. All right. Now, I am not finished. Although it may seem like I am, I'm hoping that you guys see this and think that there might be something else to do. You may not know what it is, but hopefully you see this and think that it looks like there might be something more to this. I'm going to go ahead and rewrite the square root of 6 as its product. So plus the square root of 2 times the square root of 3, that's 6. And I'm going to do the same thing in the denominator. Now, just like what I stated before, if there's something in common between every single term, they can cancel. So the reason why I did this is because I have a square root of 2 here, here, and here, and that means they all cancel. So this first square root of 2, and I divide it by the square root of 2, or cancel it out, it becomes 1. It doesn't go away entirely, it becomes 1, plus the square root of 3 all over the square root of 3. And I believe I have been telling you guys that I don't want radicals in the denominator. However, when you're simplifying these just to gain the concept, that's okay. If you'd like to go ahead and rationalize this, you are more than welcome to. In fact, if you were to rationalize, let's see what it would look like. Rationalize. All right. Spelling is not my thing. So that means 1 plus the square root of 3 over the square root of 3. That means I'm going to multiply this by the square root of 3 over the square root of 3. So when I do my denominator, the square root of 3 times the square root of 3 is the square root of 9, which gives me 3. And when I do the numerator here, this is distribution. Okay, so be careful when you do that. So 1 times the square root of 3 is the square root of 3. And the square root of 3 times the square root of 3 is the square root of 9, which once again gives me 3. So this is the preferred version. However, if you'd like to, for right now, you may leave your answer like this too. That's okay. I'm just making sure that you can get from the beginning to the end. And that concludes this tutorial.